This is conceptuality8 video that goes along with the writing in pure conceptuality. We've been talking about the language of form, and I wanted to show you some aspects of that language. Here we have our tetrahedron, which we've already demonstrated is the number 4 in the Arabic numeral sense, the way that we described it in the writing. And also we have shown this to be the concept of unity, where there's the content and context for unity, because this is the simplest possible form. It's the turnaround point, where we demonstrated that visually with our turning our tetrahedron inside out. It's the turnaround point conceptually. This can be seen as a masculine symbol. Here it is, sharp and pointed and aggressive, like an arrow or a spear, a throwing star, whatever. Here we can visualize it as embracing and holding a cup, just nurturing. We can bring the two together, male and female, and we have the male-female union. I mean, that's pretty interesting. You can't do that with a cube. I mean, so we discussed in the writing and have shown models of the octahedron. We understand how the octahedron comes in, is self-generated out of the tetrahedron, right? It's right in there. When the tetrahedron gets it becomes 2 frequency, and the octahedron comes out of the tetrahedron. Okay, now we know that we proved that the octahedron had a volume of 8, right? And we wanted to show you some transformation here, a really amazing transformation. This has a volume of 4. I'm sorry, it has a volume of 4 tetrahedrons, and we proved that in the writing. It has 12 struts, and it has 6 intersections. Okay, by this simply moving the strut, we haven't taken anything, changed anything else. We haven't even removed the strut. We just move it, and look what happens. We still have 12 struts. We still have 6 intersections or vertexes, but all of a sudden we have 1, 2, 3 units of volume. That there's a tetrahedron that disappeared in that transformation. I like to think about that like the right and left hand glove. That tetrahedron is conceptually still available. I mean, it would come out here, right? Now that brings us to the change from crystalline matter. I mean, just in concept, that we think of the octahedron as inanimate, as crystalline, because it fits into this octet matrix where everything in stop time is accounted for and uniform. But as the first 3, well, actually we could say the first 4 tetrahedrons in a tetrahedron string, we come up with the tetrahelix, right? So here's the helix, and here's a matching helix. Now, if you put them together, they don't quite fit. There's a little bit of tension in here, right? And that would be quite nice for the unzipping angle for the DNA and RNA, right? It's built in. Okay. Now we talked about the octet. Here's the octet manifestation, right? Which becomes the cube. All right. This cube has an edge length of the square root of 2, as we explained in the writing, and this is a discrete length. Also, that is the XYZ axis of the cube, which represents connecting the points of the cube. Now here it is. You can visualize it. I've got it right here. And here's the XYZ axis, which represents another tetrahedron which fits into this array. Another octahedron, I'm sorry. And I can show you on the other side that octahedron going in, right? Also, there are octahedrons that go in here. And they're all interspersed with tetrahedrons, making this a complementary array which fills all space perfectly well, and in what I call an absolute zero condition. When you realize that that each one of these edges, the square root of 2 edges of this cube, there's 12 of them, and each one of them represents one of the axes of the XYZ of the octahedron. So each one of these is 1/4 octahedron, which it represents 1 volume of tetrahedron. So if we have 12 of these, we have a 12 tetrahedron volume. We have the 4 of the octahedron in the middle, and we have the 8 of the tetrahedrons on each face of the octahedron, which adds up to 12 and 12, which is 24. So the rational volume in tetrahedrons of this octet cube is exactly 24. And all through this conceptuality, this kind of whole number comfort is going to prove itself over and over again. I know it's a lot each time. It's a lot of information, but we'll get in. We just have to present it some way, and it gets more and more specific in the math and so forth as we go along. But just in general, understanding this as a language, these things are self-evident and amazing. Okay, that's going to be it for this one.